Do you need exhaust back pressure? Well, actually no. I heard about this back pressure thing about 40 years ago, but it's probably been around a lot longer than that. But if you've ever squashed an exhaust pipe while four-wheel driving or melted a cat so it blocked the exhaust, you would have felt the lack of horsepower. I used to have a butterfly in my tailpipe to reduce noise, and when activated it used to cut the area of the pipe down to half. I didn't feel much difference until I got to about 4,000 RPM, then you could definitely feel a power reduction. This is one of those things where they could feel the lack of torque down low when they changed to a bigger exhaust pipe, but didn't know enough to explain it. They probably reasoned along the lines of, I bolt on a free-flowing exhaust, now my bottom end is a bit dead, so it must be flowing too much. So restrictive is better, and therefore it must need back pressure. What they should have said was, the pipe diameter is now larger, but it has roughly the same volume flow, so the velocity must be slower. Therefore the torque curve has shifted higher. You used to notice this phenomenon more in the old days where manufacturers used to treat manifolds as connection devices rather than power adders. So they made small convoluted connection devices, and when you swapped that out for a large pipe it made a lot of difference. We have better exhaust pipe from manufacturers these days, but you still notice this phenomena because of people's perception of what an exhaust pipe should be drives the market to make oversized pipes. Basically, aftermarket exhaust manufacturers cannot sell the general public the correct size pipe for the applications due to their perception that it looks too small for the application. And that means they have to manufacture pipes too big for the application or they won't be able to sell them. Just compare an original manufacturer's modern style exhaust manifold to a eBay header and you'll see the eBay header is a lot bigger. And considering the eBay header has gentler turns, it doesn't really need a bigger diameter to have increased flow. This is probably what they're experiencing with the smaller pipe, more torque in the normal driving RPM range. Generally, pipe diameter dictates the amount of horsepower and the length dictates the tune point, but pipe diameter can also affect the tune point. Like if you double the pipe diameter, you need 4 times the length to be tuned at the same tune point. Generally, wrong pipe diameters are out by only about 10%, so they're not going to move the tune point by a massive amount. We had a customer come in to service the cylinder head of its Triumph Dolomite lap sprint car. The cylinder head is an unusual design, but I could see the ports are the usual high-flowing 4-valve ports, so not really worth porting. So I asked him to bring in his manifolds, and straight away I could see the exhaust pipes were way too big for the application. They were ludicrously large, like the pipes in this photo, maybe inch and 7/8, when they should have been closer to inch and 5/8, like in this photo. He took the dimensions to his exhaust guy, who's supposed to be an expert on these engines, and he said it wouldn't work because the pipe diameters were too small. But the owner stuck to his guns and said to him, just make it. Well, the car made 4 more horsepower at peak, but 20 more horsepower everywhere else, which is massive, and went from second last to second fastest just overnight. The faster car was actually turbocharged, and his was only normally aspirated. On a side note, the Triumph head is quite unusual. It's a 16-valve engine with single overhead cam that directly activates the inlet valves underneath, and then with a large rocker activates the exhaust valves with the exact same lobe for both cases. In the US they have a high altitude drag strip, maybe in Colorado, possibly Bendermere, but because there's 10% less air up there, normally aspirated cars go 10% slower. Then one day Warren Johnson, 6 times NHRA Pro Stock champion, suddenly started going faster and was only losing 5%. He figured since there's 10% less air up here, the velocity must be 10% slower. So to get the velocity back, he needed to make the pipe smaller. It worked, so he went faster. On a side note, nobody could figure out the trick that he was using because he fooled them into looking in the wrong place. He knew he couldn't hide the pipes because they're in plain sight, so he put a cardboard box around the inlet manifold. So everyone's trying to look to see what's behind this cardboard box and not looking down at the exhaust pipes. You don't win Pro Stock 6 times without being super smart. Another thing about pipe diameters is, the higher the VE of an engine, the smaller the pipe diameter should be. As an example, if you have a 351 cubic inch motor with a VE of 80%, it'll make about 450 horsepower, and it needs a primary pipe diameter of 2 inches. Now that the exact same engine with a volumetric efficiency of 120%, it'll now make 800 horsepower, and that needs a primary pipe diameter of 1.9 inches. We have a 400 cubic inch small block Pro Stock class down here, and this car was fastest for 3 years running back in the mid-2000s. And when I checked the pipes, it had the smallest ones in the field. Just eyeballing it, when you measure things all day you can just look at something and tell the dimension, and it looked like inch and 7/8 to 2 inch to 2 1/8 inch stepped header, which is practically the same dimensions as you use on a street engine. But the merge collector would taper down to something like 2 3/4 inches, which is a bit small even for a street engine. If you compare this 1000 horsepower 10,500 RPM race motor against a 600 horsepower 7,500 RPM high performance street motor, it's quite surprising that they both use the same pipe diameters. Another example of small pipes is when a NASCAR exhaust pipe builder actually built an 1 3/4 header set for a NASCAR motor, which make 900 horsepower at 9,000 RPM. On the dyno, the small pipes made 6 more horsepower everywhere and only dipped under the normal pipes at around 9,000 RPM. The truth is you can never really get rid of all back pressure because a simple turn has a restriction, and in some cases you might trade back pressure for velocity to gain an advantage, but you never want to force it like the old timers say, because it's akin to blocking the pipe. We've seen how important velocity is, i.e. pipe diameter, so let's see what happens to pipe length. It's easy to ruin a good engine design just with a wrong manifold dimension, and it's usually the exhaust that's a prime candidate for this. We had a customer running a 4.4 litre Leyland V8 in his RX-7. The Leyland V8 is just a larger capacity Rover motor, and the RX-7 was just a body shape. Underneath it was a fully fabricated tubular chassis. He just got its heads ported at the biggest, most well-known cylinder shop in the city, but it was still running 20th, 22nd on the field. So he came to us, and when I floated, it didn't flow much more than a standard head, which was weird considering the other cylinder shop had a flow bench. We found out later on by an employee that they never used it. So I ported another set of cylinder heads, and now we started qualifying round 5th and 6th, which is not too bad for a $12,000 car, considering the cars on the front row were at $200,000 cars. But the one problem he had was it never revved over 6,000 RPM. So he asked if we could figure it out, because he'd tried all the usual suspects like ignition and fuel pressure under full load. We never saw the car, nor how severe it was, and he never told us about the telltale signs. So to us, it looked like a manifold length was too long and tuned for a lower RPM. And because we only saw the cylinder heads, the inlet manifold and the carbs, we thought the inlet length was too long. The inlet manifold was individual runner that crossed in an X shape over the valley to quad side draft Webers that ended up being positioned over the rocker cover on the opposite bank. Since all Webers have a long inlet trumpet, we told them to replace them with just a radius plate, making the inlet trumpet effectively 12mm long. The car would now rev to 6,500, but the problem still wasn't really fixed. So to try to figure out the problem, he took it to an engine dyno, and during the pulls you could see a fuel fog form in front of the carburetors. This is called fuel standoff or spitback, and it's because something is so far out of tune it's pushing the inlet mixture out the trumpet and quickly drawing it back in again. Basically the inlet air passes the main jet 3 times, so it meters 3 times the fuel into the air. The dyno operator Australia thought the inlet trumpet length was too short, so they put the old trumpets back on and the fog went away. What the guy didn't realise was the fog was still there. It was just inside the trumpet so you couldn't see it. As soon as he told us about the fuel standoff, we said, "Show us your exhaust." And sure enough, the primary pipes were 10 inches longer than they should have been. We thought he bought the headers. Aftermarket headers aren't too bad lengthwise, but he fabricated them, and he moved the collector right back to clear a chassis rail. We also had a customer with a 34 Ford Coupe hot rod that did the exact same thing. It was nothing fancy, just a 500 cubic inch big block Chevy with Edelbrock heads, pump gas and fuel injection, basically performance street. And when we went to the strip for its first time out, it did a 10.3 at 135 mile per hour. The ET tells you how good the chassis is, and at 10.3 it's a pretty average chassis. And the mile per hour tells you how much power it has, and 135 mile per hour, that's pretty good. And when we went to see the owner, he said he loved the engine, just that it spat fuel under the bonnet. And as you guessed it, a quick look at the exhaust pipe and it was too long. This is kind of a lesson for people that fabricate pipes and think any length will do. And in fact, aftermarket shelf headers usually aren't that far out lengthwise. Even the short ones are safer, because they can use a different harmonic even though it's weaker. Hopefully this will give you a better insight into what exhaust pipes do, so you can make a better judgment when you buy some.